Welcome back. In this video, we're going to compute this integral from MIT integration B. So the integral, we're going to call it I. It's between 0 and 2 pi of the function f of x. In this case, it's equal to cosine x times cosine 2x times cosine 3x. One key to solve this question is that we're going to use a transformation to get rid of this product. Okay, and one key idea is that we know that the cosine of A times cosine of B is 1/2 cosine of A plus B plus cosine of A minus B. Here, this result, we can prove it easily by expanding the cosine of A plus B and the cosine of A minus B. And once we do that, we get this result here. Okay, and this is what we're going to use to prove this result. Okay, another thing that we're going to use, so this is the key idea. The second key idea is that, so the integral between 0 and 2 pi of cosine of alpha x dx with alpha some let's say some integer, it's always gonna be 0. Why? So if we can do it geometrically, we can do it by using the antiderivative. So here we have this this is just 1 over alpha sine alpha x between 0 and 2 pi, which is 1 over alpha sine of 2 pi alpha minus sine of 0. Here 1 over alpha, and this one sine of a 2 pi alpha, so this is always 0 too, so therefore we have 0 minus 0, which is 0. We're going to use this result here to get the result quickly. Okay, so let's first expand these three products into some sum using this idea here. Okay, so the first one is cosine x times cosine 2x. It's going to be 1/2 cosine, here a is 1 and b is 2. Therefore, we're going to have cosine 3x plus cosine of a minus b, which is minus x, but since the cosine is even, we're going to have x. Okay, now if we multiply by the cosine 3x, we're going to multiply this one as well by the cosine 3x. We're going to have 1/2 in the front, and we're going to have cosine 3x times the cosine 3x plus cosine x times cosine 3x. We're going to reapply the result here. This result here one more time. So when we do that, we're going to have 1/2, which we will multiply by 1/2. We're going to have 1 over 4, and we're going to write this one in a simpler manner, which is these two, the cosine of 6x plus cosine of 0, which is 1. Here we're going to have the cosine of 4x plus the cosine of 2x. Okay. And therefore, when we integrate here, we're going to have I. So the integral between 0 and 2 pi of cosine x, cosine 2x, cosine 3x dx. It's going to be 1 over 4. The integral between 0 and 2 pi of 1, this one here, plus cosine 2x plus cosine 4x plus cosine 6x. Okay, so in our case, as I proved here, okay, so if we take alpha as 2, 4, and 6, this one will give us 0. Therefore, we're going to have 1 over 4, the integral between 0 and 2 dx, plus the integral between 0 and 2 of cosine 2x, plus the integral between 0 and 2 pi of cosine 4x, plus the integral between 0 and 2 pi of cosine 6x. So here, as I proved, this one is 0, this is 0, this is 0, and therefore we are only left with this one, which is 1 over 4 times 2 pi, which is pi over 2. Okay, this means that our integral, we did answer the question here, that this is just pi over 2. Okay, so the key idea to solving this is one way, because the products are difficult to deal with. It's better to have sums without the powers, without square 2, power 2, 3, or 4, or something like that. It's always good to have this one in a nice sum without powers. The powers, they make the integration very difficult. Okay, so this is the result that we get, and I think that we answered the question. Okay, thank you very much. If you see any errors, please let me know, and I wish you a great day.